Hello everyone and welcome to a video on the riveting topic of detailing your landscape. By the end of this video, you should be able to take something that looks like this, which is a single texture landscape material with obvious repeated grid tiling in the foreground and vanishing lines in the background, and turn it into something that looks like this. I've broken up the tiling in the foreground, as well as the vanishing lines that happen with tiled textures in the background. Before I begin, I would mention that there is no one-size-fits-all solution to detailing. Depending on the size of your scene, the camera angles, the textures you use, the amount of stuff that's in your scene, you may need a lot of detailing, you may need a little, and the ways that you go about that may vary. I will show you a couple of the tricks that I use mainly to get rid of landscape tiling, and also hopefully put you in a good place to be able to experiment with other techniques on your own. The best way to position yourself for successful detailing is to choose a texture to start with that is uniformly random. For example, this grass. This grass is from Quixel Megascans, and it's pretty good. There's no single distinguishing feature of the grass. There is a little bit of a swish pattern here, which is causing the most part of the repetition, but for the most part the grass all looks the same, it's the same color, and there's a good amount of noise and randomness to prevent very obvious tiling. On the other hand, if I were to take a different material, a different texture, something like this mud, let's have a look at the mud texture. And although I've seen what it looks like now, without even looking at the scene, I know that this texture is not going to tile great, or rather, it's going to tile very obviously, because there is a single big old rock in the center of this texture. And this rock is going to repeat and repeat and repeat, causing, let's have a look over here. Right, up close, this rock is very clearly on a grid, which is obviously fake. And in the distance, depending on how YouTube has compressed this, you might see this or not, but in the distance on my screen, the rocks have sort of blended together and formed a line. And that line creates a vanishing point in the distance along this axis, along the 45 degree, along the 90, and so on and so forth. So there are many places in the scene where these big features have sort of caused visual artifacts that we don't want. Because of this big single distinguishing feature, detailing this is not going to be super easy. Let's have a look at what that detailed material looks like with this texture. So even though I was able to break up the obvious gridding of it and the obvious tiling, that feature is still a very repeated visual feature in the scene. So you may want to choose a texture that is not, that doesn't have something as obvious as this one does. However, I will use this as a hard mode texture and continue coming back to it as a reference for how my detailing material is coming along. The last thing that I'll mention before I begin is a very basic concept, but it's good for us all to be on the same page. And that's UVs, and what a UV map is and how it relates to our texture coordinates and our texture. So a UV map is a square that contains values between 0 and 1 along the x and 0 and 1 along the y, moving up to 1 and 1 in the top right-hand corner. Because x corresponds to red in an RGB format and y corresponds to green, our UV square looks like a red gradient moving along the x, a green gradient moving along the y, and a yellow gradient moving diagonally from the bottom left-hand corner to the top right-hand corner. And when we sample a texture, we use these coordinates. So if we're sampling a texture onto a square object, so like a plane, the texture will, if the texture is square, the texture will map onto that plane 1 to 1, with the bottom left-hand corner of the texture being at position 0, 0, and the top right-hand corner of the texture being at position 1, 1. For something like a landscape, the landscape's coordinates do not range from 0, 0 to 1, 1, but from 0, 0 in some arbitrary corner to some really big number on the opposite corner. Because materials and texture samplers in Unreal know that to sample a texture you need a value between 0 and 1, whenever a coordinate goes above 1, it wraps back round to 0. So when we are dealing with our landscape, even though our landscape is really, really huge, and the coordinates range from 0 on one corner to some massive number on the other, at any point, if we apply a texture to that landscape using the landscape coordinates, that texture will be wrapped around until it's some value between 0 and 1. What that looks like is if we apply a UV texture with a flat normal, just to see, without any of our denoising. So here are these textures applied to the landscape, these UV example textures applied to the landscape with the wrapping on. And that's what causes our tiling, because when the coordinate goes above 1, it wraps back round to 0, and we have the next sort of wrapped tile. The point of all of this is that the landscape coordinates, the texture coordinates coming in from the landscape, are going to be some huge number, which then the texture sampler will wrap around to be between 0 and 1. Let's have a look at what that means for us in practice. I'm going to create a new material called mdtiler and create an instance from that material and put that instance into my landscape. All right, we have a completely blank material. Let's go in and see what that looks like. The first thing that I want to do is add a texture sampler. And the texture sampler is sort of at the core of what we're doing today, because the texture sampler is going to take a texture, which will ideally be a square, and use the UV coordinates that are coming in to determine which section of that picture to display. So if the UV coordinate at a specific pixel is low, is 0, 0, then the output of this texture sampler will be somewhere in the bottom left-hand corner of the original texture. And if the UV coordinate coming in is high, it'll be in the top right, etc., etc., etc. We can either choose a texture in this actual texture sample itself, so just set a texture and forget about it, or add a texture object node. And if we right-click on that and hit convert to parameter, we now have access to this texture in our material instance. Let's drag the texture into text and the RGB into base color. Also, just while I'm here, I'm going to create a 0 on metallic and specular and a roughness of 1. This will help flatten out our material a little bit so that we don't have really shiny sunspots. Excellent. That material has loaded up. So let's see what that looks like. Here we have our grid pattern. And in our material instance, we have the option to activate the texture and choose a different texture. So if I choose my UV, then we have that original image from before. If I choose my grass, then I have my grass. If you're following along, it doesn't have to be this UV texture, which I created myself. It can be from any sort of grid or tile pattern will do fine for you. All right, so one thing, the sort of simplest thing that we can get out of the fact that the landscape coordinates are really, really big is the option to multiply the landscape coordinates by some value before coming into the UV, and thus changing the way that we sample the texture. Without us specifying any incoming UVs, the texture sample node defaults to whatever the coordinates of the object for the material are. But we can be explicit about that and right-click and say, hey, I want the texture coordinates to be coming in to the UVs. Once I hit apply on that, nothing changes because it's exactly the same as it was before. However, because we now have access to these texture coordinates, we can start changing the way these coordinates are applied. The most simple way to change the way the coordinates are mapped is by adding a multiply node. And let's add a parameter called texture scale, pop texture scale in there, pop that into the UVs, and make sure that's a default value of 1, and hit apply. I just realized that I didn't have my button highlighter on. If you're confused as to what I'm doing, check the lower right hand side of the screen where you will see all the keys that I am pressing. So we added a texture scale, applied that to the material. Now in our instance we have access to this scale parameter, and if we increase the scale, the squares get smaller. That's strange. What's happening is that if the incoming texture coordinate is some value between 0 and 1, and we multiply that by 2, that means that that value is now somewhere between 0 and 2. So if we consider that the texture sampler wraps values greater than 1 back to 0, then our new texture will be mapped from 0 to 1 at the halfway point, and then back round to 0 to 1. So we're fitting 2 squares where there was originally 1 square. Similarly, if we say multiply this by 0.5, now the original 0 to 1 is some range between 0 to 0.5, meaning that the 1 is somewhere on that side. So we're fitting half the size of the squares in the original square size. For this reason, this is sort of counterintuitive. When I say I want a big scale, the things get smaller. When I apply my scales, I usually don't use multiply, but use divide instead. And that way, pop that into the UVs. And that way, when I increase the scale, the size of the squares gets bigger. So that's a little more intuitive to me. And so we have arrived upon our first detailing technique, changing the scale. If we take our grass texture, let's take the Unreal default ground grass texture, which comes in the starter content, and we the original scale is 1, and we scale that way up to 5. We have, at least up close, we've begun to remove some of that tiling. So the original, the scaled version, you can't see that it's tiled. Obviously, this is not what this video is about, but this is the beginnings of what we're going to start adjusting. By dividing the UVs, we've given ourselves the option to make a texture really, really big or really, really small. Great, so now that we've wrapped our heads a little bit around what UVs are and how we can begin to adjust them in our material, let's look at the first legitimate, actual detailing technique of this video. First of all, open up the material, have a look at what we've got going here. I'm also going to change the default here to be the grass, just so that I can see this flow a little better. The first technique is one that you will probably have seen in a lot of the default starter materials or many introductory videos. It is a very straightforward method that works relatively well. The default premise is to take the color that is coming in and then in patches slightly increase patches of the color and then slightly decrease other patches of the color. To do that, what we need is a noise texture. The starter content provides us with one of these noise textures. So I'm going to create a new texture sampler and create a new texture object from that, for that sampler called texture object. I'm going to convert this to a parameter called macro variation texture. Pop that into the texture slot, and then for my UVs, I want to create a different scalar value from the original texture scale, because the whole point of this is that we're going to be scaling this noise map at a different to a different size than the actual color texture of the material. So we'll take this texture coordinate and we will then divide that by a new parameter called macro variation scale. I'm going to set the default of this macro variation scale to 1 because we don't want to ever divide by 0. That would cause chaos in the universe. And divide our texture coordinate by this scale, and then pop that scaled value into the UVs. The actual texture that you use for this is up to you. Any sort of noisy texture should do the trick, but there is this is such a common technique that provided for you in the starter content is a texture called macro variation. So I'm going to choose macro variation, and if we look at the actual texture, this is a generic, noisy sort of texture with fine details up close, and then also a lot of different patches far away. So this will do for our needs. Now I need to apply this texture onto the original color of the landscape. There's a few different ways to apply these color variations. I'm going to use a multiply node. The output of what I want is for the brighter areas of this noise variation to increase the brightness of our landscape, and for the darker areas to slightly decrease the brightness of our landscape. The way that I do that is to first of all multiply the noise texture by 2. So we're changing the output range of this from 0 to 1 to 0 to 2, and then subtract 1. This is a very common step to change a range from 0 to 1 to -1 to 1. And that means that our brighter values are going to be closer to 1 and our darker values are going to be closer to 0. And the reason that I've done this is so that I can apply another multiply node here with a parameter. And this parameter is going to be macro variation amount or influence or something along those lines. And if we multiply the -1 to 1 values coming out of this sampler by small numbers, we are decreasing that range closer to 0. And then if we multiply them by numbers above 1, then we're increasing that range. This is going to change the amount that this noise map influences the final color of our scene. Lastly, because I want to use a multiply node to apply this texture sample, right now the average of this texture is going to be 0. And if you multiply something by 0, you get a black 0 output, a dark 0 output. So the final step here is to add 1 to this, and that changes whatever those values are, whether it's a big range centered on 0 or a small range centered on 0. That's going to change the output of that range to be centered on 1. So if we apply by the average 1, then there's no change. And if we apply slightly above 1, then there's a brighter change. And if we apply slightly below 1, then there's a darker change. Great, so let's do that. We will add a multiply node and multiply this whole thing, which I'm going to press C to add a comment and call this, it's actually just brightness. So the brightness variation, multiply the brightness variation by the, oops, god damn it, by the original color, and hit apply. Let's have a look at what that looks like in our landscape. So far, nothing much has changed. Let's have a look at why. So check in the instance. Well, there's two reasons, and both of them have to do with the default values of these parameters. The variation amount is currently at 0, so there's no influence. But if we start increasing that, you'll see that something's happening with our grass, but it's just accentuating that original grid pattern. That's because the scale of this texture is still at 1. So 1 is the scale of the original texture, which means that our noise texture is just applied 1-to-1 on top of that. And that's going to accentuate your grid rather than de-accentuate it. So what we need to do is increase the size of the noise texture by a little bit. Not by a little bit, by a lot. So if we change that to 3, really up close, we've started to break apart the tiling of the grass, but in the distance, we've still got that really big, we've still got those vanishing lines. So what we really want to do is increase the variation scale to some relatively big number. And depending on the size of your scene, this number will absolutely change. And now the color variation in the background has really gotten rid of all of those vanishing lines. But this color variation is quite intense, and that's maybe not what we want. The nice thing about this technique is that you really only need a very subtle color change to break up those vanishing lines in the distance. So even, actually 0.1 doesn't do it in this case, but 0.3, that gives us enough of a visual change in the distance to overpower the vanishing lines. Your mileage may vary on this, of course, and depending on the brightness of your original material, you might need to change the variation amount and the variation scale, which is why I like to parameterize these rather than set them in stone in the material itself. And that's really all there is to it. The first technique is about applying some sort of noise map brightness variation to the original color, and then scaling the texture of that noise up really, really big so that we have brighter and darker patches throughout the scene. However, it has not done the complete trick because there are still very obvious repeated patterns in the middle distance and up close, and even if we look carefully far away, the color is just covering up the vanishing lines and not actually removing them entirely. So let's move on to something that's a little bit more robust. The glaring issue with the brightness or color variation method is that it doesn't actually fix the tiling. It just covers it up. It sweeps it under the rug. What I want to do next is show you a way to break up the actual UV tiling by applying a noise map and based on that noise sampling different sections of the image. So we'll be breaking up the square tiling by not actually sampling full squares anymore. There are a number of ways to do this, so just to get started on the concept, I'm going to show you one of the simpler ways. Let's go back into our material. Before I jump in, I do want to clarify that for this demonstration, I've only been using a single texture, the color, but we can include normals, roughness maps, ambient occlusion, displacement, or what have you, and the same concept will apply. Just for the heck of it, I will include a normal map here as well, so that you can see what that process looks like. So I'll call this the color, and then add another texture sample with a texture object. I'll parameterize this and call it. Pop the normal into the texture and then take the same coordinates going into the color sampler into the normal sampler. And that's the important step. Whatever maps that you have, you need to make sure that the UVs coming into one are the same as the UVs going into the other. So I have the starter content normal going into our normal now. And because our color variation was only affecting the color, we didn't have to do anything different or strange to the normal in that case. Now that I have my normal map, I want to work on breaking up the tiling. One of the more straightforward ways to do that is to duplicate the texture sample and sample the same texture slightly differently, and then blend between those two differently sampled textures for the final output. So we will duplicate the texture sample and sample the same texture, and then somewhere downstream here we're going to blend between the two in some noisy manner. But before I do that, I need to decide how I'm going to sample this differently. The way that I like to do this is to multiply by a small amount, something like 1.13. So at the very least, the squares won't line up because they'll be scaled slightly differently. And then rotate, use a rotator node to rotate these coordinates. So we'll drag the coordinates into coordinate, and we'll need some value in time. Time just means the amount to rotate. So I'll create a parameter called rotation amount, and pop rotation amount into time, and then take the output of that into the UVs. So to clean up this graph a little bit, we've got our original coordinates with the scale coming into the first texture sample, and then we've scaled the coordinates slightly smaller because we're multiplying, and then rotated them by some amount. I'll leave the rotation amount at 0 for now, but one thing to note is that the rotator has, if you click on it in the details panel, there is an option for speed. I don't know why the speed is at 0.25 by default, but I'm going to change that to 1 so that the time value coming in corresponds to, I believe, radians. And we'll look at that in a little bit. So on the output of this, we have one texture that's going to be the original, and then the other texture, which is going to be rotated by some amount. And I need to blend between them. For now, I'm going to create a switch node and pop the original into true and the changed into false, and then add a bool, which is just a yes, no, true, false value. Call this texture switcher. Pop that into there, and then we'll take texture switcher into our original color value. And all this is going to do, I'm not going to leave it in my final material. This is just going to allow me to toggle between these two textures in my material instance. Great. Now in our material instance, we have a new option to enable the texture switcher. And when I hit that button, something changes, but it's sort of difficult to see what. So let's change the texture that we're using back to that UV texture, or some way that whatever your reference grid is. And I'm also going to set the normal to flat, just so that our normal is not interfering with us at the moment. Now with our UV texture, we should be able to see what's happening a little bit more clearly. When I flip this button, pay attention to what's happening to the red lines and the green lines. Great, so when I switch this bool, you can see that one set of squares is slightly larger than the other, and that's because of that multiply node. There's no rotation at the moment because I have not changed the default from 0. When I am false, that's when the rotation is applied, so that's when I have access to the rotation amount. And if I start increasing that to something like 3.141, now when we toggle back and forth, you can see that the green and the red, indicating which axis we're on, have completely rotated. And if we choose 3.141, which is an approximation of pi, divided by 2, then we will be rotating by around 90 degrees, so half pi. And then if we divide by 2 again, quarter pi, which will be 45 degrees. We have completely changed the way that the texture is applied onto the material, onto the landscape, just by rotating the UVs. Now that we've done that, we can, instead of toggling back and forth manually, we can say, okay, we want certain patches to be one way and certain patches to be the other. And whenever I'm talking about patches, I know that I'm going to want a noise texture. So I'm going to add in a noise texture. And this time I'm not going to use the macro variation. I'm going to use a different type of noise called Perlin noise, which is a wonderfully versatile, built into the starter content. So if you don't have the starter content, grab it. This noise is a texture that has sort of gradient variation from on a large scale, from lighter areas to darker areas. And then when we zoom in, on a small scale, there's sort of micro variations down on a small scale too. Essentially what I'm going to do here is say, in these lighter areas, apply one texture, and then in the darker areas, apply the other rotated texture. And if we scale the noise map up a little bit, we should be able to break up that grid tiling enough to fool the eye into thinking that it's not the same texture repeated over and over and over. Excellent. So what we need to achieve that is a way to scale the noise map. So I will have to create a parameter, call this, my names are getting a little bit outrageous at this point, rotation noise scale, and take the texture coordinate, divide by the noise scale, which I will set as a default to 10 for the hell of it, and then divide and pop the output of that into the UVs. And for now, I know that I'm going to use Perlin noise, so I'm not going to parameterize the texture here. I'll just keep it as is. Cool. Now that we've got our noise map, the next step is to blend between these two textures using this noise map. Whenever I'm talking about blending two things together, I know that I'm going to need a hold down L for lerp node, and I will lerp from one to the other based on some sort of input. So let's delete that switch node and pop the output of the lerp into our original color. Now, it's tempting to say, okay, we've got the output of our texture, let's just pop that into the alpha. The problem is that if we look at this texture, the gradient between the darker areas and the lighter areas is quite soft. There's a lot of gray between very dark and very light. And if we're blending too much of the texture together, if too much of our texture is like half one and half the other, then that's just going to reveal the grid of both. What we want is some areas which are definitely one way and some areas which are definitely the other. So to kind of fill in this, to reduce the amount of gradient grayness in these middle areas, I'm going to use a contrast node, which if we search for cheap contrast, I assume that means that it's easy on the graphics card. We can take the output of our texture sample, pop that into contrast, and create yet another parameter here called rotation noise contrast. And I'll leave that as a default 0, and then we'll play around with it to see what it does. Just to mention, I am parameterizing a lot just to show you what each value does when we adjust it. Once we've sort of settled on a contrast and settled on a scale that works for us, we might want to remove that as a parameter just to clean up our material instance a little bit so that we don't have an overwhelming amount of options. For now though, I will keep this as a parameter and then take the output of the contrast into the alpha. One last thing before we apply this, contrast is great because it will crunch the darker areas and then bring out the brighter areas and sort of shrink that middling gray area. But it can be good when you're dealing with contrast to also have a way to adjust what that midpoint is. And the way that you adjust the midpoint is by adding yet another parameter, which I will call the rotation noise midpoint, and I'm going to add the midpoint to the output of the texture sample and then pop that into contrast. So when we add nothing, it's the original, and then when we add higher values, our midpoint will be slightly brighter, and when we add lower values, our midpoint will be slightly darker. So I will create this as a slider between negative 0.5 and 0.5. Excellent. Let's clean this up a little bit. Take the, call this rotation noise. Space things out a little bit. We'll call this section over here the rotation textures. Okay, now that we've done that, let's go over and see what this all looks like. We can begin to see that we're getting blends between the 45-degree rotation, so the quarter pi rotation under rotation amount, and the original straight lines along the world axis. But as you can see, because of the grayish gradients, we're exposing both the 45-degree grid and the original grid. So we haven't made it better, we've made it worse. But once we go into our contrast parameter and start increasing that contrast, we're now solidifying the borders between the higher values and the lower values. And once we get that to something around 10, we've got patches which are definitely one way and patches which are definitely the other. When we zoom in way into here, there is still a tiny little bit of a gradient, but it's small enough that we don't see it. The scale is coming in at a default of 10, which means that we'll still be able to see repeated tiling patterns at about a scale of 10. So what we might want to do is increase that scale a little bit and see how that is breaking up our pattern. The other parameter that we created was the midpoint, and as we slide the midpoint closer to negative 0.5, our original grid shows through more than the other, and then as we slide the parameter towards 0.5, we get more of the rotated texture. I'll keep that at 0 for the moment, but that's a good way to favor one over the other. I think I'll increase the noise scale just a little bit more. Alright, so using our UV reference, we've been able to see that we have patches that are one way rotated and patches which are another way rotated. But let's see what that looks like with an actual texture. Let's go into our grass. So this isn't actually too bad. When we look around, I don't notice any massively repeating patterns. It is still very obvious that there are vanishing lines. So this method is for noise that's close up and not necessarily getting rid of it far away. But if we bring in that variation, if we bring in that color variation again to get rid of the repetition in the distance, then we've got a good blend between broken up close-up grid as well as broken up distant vanishing lines. But this grass is relatively uniform to begin with. I mean, even the original at this scale isn't super noticeable. So what if we use that problematic mud texture from before, which has the single feature in the middle? So this is what it looks like with, as actually it's negative 0.5, right? As an original, very obvious, very grid-like. And then when we change the blend to full blend, we have at least started to break up that square repetition. As with the grass, it's still quite obvious that there are vanishing lines, but as a solution for close-up noise tiling, this isn't too bad. One thing you may have noticed is that in the middle distance and in the far distance, we still have these parallel lines. Because our rotation amount is quarter pi, so about 45 degrees, we've almost accentuated the parallel lines both along the original axes as well as along the 45-degree axes. So that's not super ideal, and we will need to blend this with some other technique to handle the middle distant and the far distant noise as well. One thing that we could do to begin to alleviate that is to change that rotation. Let's just multiply that by 2 and then divide by 3 to be more of a 30-degree angle. And the 30-degree angle, for the most part, gets rid of the 45-degree angle artifacts, but now we have artifacts at the 30-degree angle. So no matter what rotation you choose, there will be certain angles where you can still see some of this repeated patterning. One way that you could begin to get around that is to layer more rotations on top of each other. So in our case, we have layered 2 different textures. We've sampled one at the original and then one at a 45-degree rotation. But perhaps you have 3 textures and sample one at 0, one at 30, one at 60, and then blend those all together. Or you split it up into increments of 10. You could do that. I don't necessarily recommend it because the more texture samplers you have, the heavier this is going to be on performance. And also, it's tedious to set that type of thing up. The next solution that I'm going to talk about is a building on this, but rather than blending the 2 textures after you've sampled them, we're going to blend the UV maps together. So we're going to rotate the UV maps in multiple different ways, in the same sort of patchy, noisy manner, and then sample a single texture out of that. Before I do that, I should mention that we do need to perform the same steps that we made on the color texture to the normal texture and any other texture maps that you have. So in this case, to do that, I'm going to copy the normal. The first normal is from the original coordinates, and then the second normal is from the rotated coordinates. And instead of just feeding the normal straight into our material output, I'm going to lerp between the original normal, and the rotated normal. And then drag in the noise map that we are using as our blend. And then bring in the noise map which we are using to blend. Take the output of lerp into normal, and that should do the trick. Now we can pop back into our material instance, change the normal to our mud normal, and we should be able to see, once I bring the sun down a little bit, that the normals are applied correctly. It's just a little difficult to tell, but that's good enough. Great, so we've added the normal maps, and you would have to do that for your displacement or your roughness as well. I'm going to comment all of this and call this near noise, because this is good for breaking up our tiling close to the camera, but it's not good for breaking up or tiling far away from the camera, or even in the middle distance. So I'll take that all the way into the background to give us some space, and move on to something which scrambles the UVs before we sample the texture, and then we only have to sample a single texture. We start, as we've done before, by bringing in the textures that we need. So I'll start by copying both the texture and the normal, and then bringing in our texture scaling node tree. And then I know I want to do something to these coordinates before I bring them in as UVs into the texture sampler, so I will give us some space in between. Let's add a noise texture of type Perlin noise, great, and create a similar scaling process to what we did over here, but we're not going to use the same parameter. We're going to create a different parameter, and I'm going to call this scale. This is called distance noise scale because we're dealing with breaking up the patterns further away from the camera in the distance. Take the texture coordinates, divide by the distant noise scale, and make sure that our distant noise scale is default. You know what, for the default I think I'm going to choose something along the lines of 47, just as an arbitrary value, and we can play around with it. And then take the output of that division into our UV coordinates. Now we have a noise map which will be relatively big within our scene. Now I want to use this noise map to adjust the texture coordinates coming in, specifically to rotate them by some amount. Let's have a look at the texture. Previously, when we used the contrast, we created basically a two-tone image, something that was fully dark or something fully bright. In this case, I want to create a few discrete steps between dark and bright. I want to be able to say these areas rotate by some amount, these areas rotate by a little bit more, these areas by a little bit more. This is similar to the posterize effect in Photoshop or something, where you split an image which has a gradient up into discrete tone steps. One way that we can do that is by multiplying by a certain number, and this is going to be called my distant noise posterized steps. You can be a little bit briefer in your words if you want to. So I multiply the noise by the posterized steps, which gives me a bigger number, and by default I will set the number of steps to 3. So what this is going to do is change the values coming out of noise from between 0 and 1 to between 0 and 3, and then I will round the values coming out of this to create 3 discrete steps, 0, 1, 2, and 3, or 4 discrete steps, I guess. We could use floor instead, which would be a little bit more true to what I'm suggesting, but round is good. And then lastly, we'll divide by posterized steps again. So this will bring that 0 to 3 range back to 0 to 1, but because we've used this round node in between, the steps are now going to be discrete and not a smooth gradient. Excellent. So I have a noise map that goes from, I have a noisy map which is divided into discrete steps, and now I can use the output of this to begin to rotate patches of this texture coordinate. So let's add a rotate node, bring in the coordinates, and then pop the output of this whole collection into time. In fact, what I want to do is also add a multiplier and call this multiplier distant noise rotation multiplier. So this will adjust the amount of rotation that each discrete step creates. Pop that into time, and then we can take the output of this rotation into the texture samplers. All right, before I worry about distance fields and which one's in the background and which one's in the foreground, I'm just going to take the output of this straight into the color and the output of normal straight into normal to see whether this works as I intended to. Then I have a black world. Why is that? Probably because I've done something dumb. Oh, possibly this time does not want a RGB. So if we take the red channel, because this is just a black and white texture, so we take the red and then, right, there we go. So yeah, be careful about sometimes taking vector 3s into vector 1s is okay, and sometimes it isn't. Great, so we've got that. Let's have a look at what we can do with all of this in our material instance. Cool, so I've got our posterized steps, which is 3, and our scale, which is 47, and then the rotation multiplier, which will change the steps that each sort of patch rotates by. But let's have a look at what this is doing, not within the mud texture, but within that UV texture from before. Okay, so UV with a flat normal. Okay, so with a posterized step of 1, that means that we have, I guess I named this wrong because we have 2 steps, 1 being the original rotation and 1 being a slight variant, and we can increase the rotation of that variant by changing the distance noise rotation multiplier, and we'll change that rotation. So let's put that at 1, I don't know, some value that's arbitrary for now. And then we can increase the distance noise posterized steps. And once we increase that to 2, we now have different patches of noise which are rotated in different ways. So one thing that I've realized is that just like with our contrast where there's a midpoint, we might want to adjust the way that this the sort of curve, the levels of the noise before bringing it into the posterized step. Before this posterization step, which I will comment in as posterize, I want to be able to adjust the levels of this texture sample. Let's add a power node and then pop in distant noise power, which will give us a way to spread out the posterized effect a little bit better across the board. Right, so with our power node, I've changed the distant noise posterized steps to 1, so there's two different rotations here. And with our power, we can adjust the distribution of those patches. We can either say we can favor the original or favor the rotated patch. So I'll choose something that's around halfway between the two, 1.2-ish, and change the posterized steps to 2. Ugh, now I've got to do that whole thing again. So use the power to adjust the distribution of the patches. So already with just the UV texture, I can see that in the distance, or at least in the middle distance, the patches are breaking up. And if I had something that wasn't an actual square texture, perhaps this is giving us enough visual differences among the patches to be able to break up the vanishing lines and all of that. But we do need to play around with the values a little bit more. I might increase the scale just a smidge. Perhaps change the rotation multiplier as well. So these values are here for you to tweak. I am getting something that just sort of breaks up the lines in all different directions. Let's see what that looks like with a different texture applied. So something like, I might choose a different, let's have a look at what the mud looks like. Right. So what's happening on my screen at least is that in the middle distance, the texture is broken up quite nicely, and I don't see any vanishing lines off into the distance. But close up, it becomes a little bit more obvious that there are patches of repeated patterns. So here's that grid, here's a grid, here's a grid. So now what we want to do is blend the distant noise, the one that we've just created, which works well in the middle distance, far away from the camera, with the close noise, the noise that we created earlier, which works well close up, we're closer to the camera. There's a very simple way to do that using what is called the camera depth fade. And what this node does is creates, if you hover over this, creates a gradient of 0 near the camera and then 1 at fade length, offset by an offset. So we'll add 3 values to this. A length, so the length of the gradient, how smooth the transition is between close and far. An offset, so how far away to start this transition. And then just a boolean into vertex shader to make this process a little bit more efficient, because it will run in the vertex shader, not the fragment shader. Cool, so we'll need 2 parameters for this. One called fade length, and by default I'm going to say about 500. So at 5 meters away, the fade length will be 5 meters gradient, and then the fade offset is also going to be 500. So starting at 5 meters away, create a fade over 5 meters. And the bool is going to be a static bool of type true into the vertex shader so that this runs slightly more efficiently. Great, then we need to choose what we are fading between. And here I have the macro brightness variation, which I want to apply to everything. So I'm not going to fade after macro variation, I'm going to fade before macro variation. 0 is near the camera and 1 is distant from the camera. So we'll use this to fade from, using our lerp node, we will use this to create a transition from 0, which is close to the camera, so our original near noise, to the value coming out of this whole mess of things, which is our copy, create a comment around there and call this distant noise. Just named this distant noise. So we'll take the output of our distant noise into B and fade based on camera depth fade. I'll spend a hot second cleaning all of this up because this is gross, and then take the output of lerp into base color. I'm going to do the same process for the normal map as well, and if you had other texture maps you would have to do that for those too. So from near noise normal to distant noise normal, baseline, specific. Pop that into normal. And I lied because I forgot to apply the color variation. So I will take the base color, take the base color into the multiply and then use that multiply into color, so that we have our color variation as well. Cool, let's label this chunk of nodes as the distance fader and see what all of this does. Okay, our material is ready. Let's open up the material instance editor and just double check our settings. So this is where I was talking about things getting overwhelming if you've made as many parameters along the way as I have. So we've got a collection of distance knobs to tweak, and then a collection of the rotation noise, which I might go in and rename as near noise just to create that distinction. So as we move the camera in and out, which I will increase the speed of here, maybe too much. As we move the camera, you'll see that there's a fade line around here where I'm holding the mouse, where things fade from the near noise algorithm to the distant noise algorithm. So, I'm not super happy with our distant noise just yet. From above, the grid pattern is becoming a lot more recognizable because if we go into our material and change back to our UV, even though our noise is breaking up big patches, the individual chunks of those patches are still very recognizable as grids. So what I might do is go back to the material instance and start tweaking those distant noise values a little bit. Perhaps giving us a few more steps to deal with so that we've really broken up the tiling both close and far away. Right, I've tweaked the values a little bit to ensure that there's no big discernible patches of grid and everything's sort of broken up both near and far away from the camera. And I think with that, that's still a little bit liney. So here we are. I've tweaked the parameters a little bit, left lots of them at their defaults, but just try to break up the interior of each of these square patches a little bit more by playing around with the power and the posterized steps. There are other things that I could do here to help increase the sort of smaller areas as well as the larger areas. These larger areas are looking pretty good for me. I don't see any long lines along any specific direction. So if we turn this back to mud, that should have done a decent job at breaking up the middle ground textures. But there's other things that I can add to this to continue to break up this noise a little bit more. In our material, let's head back to the distance noise, the distant noise, and consider other ways to start adjusting, breaking up the UV maps even more. One common thing to do is to create another sample the noise from a different scale, and then layer them on top of each other so that you have noise that covers a vast area and then also noise that covers the more the areas which are closer up. To sample this noise on a smaller scale than the other, we can take the output of this divisor, so the original scale of this noise, and then divide that by some small number. I'm going to choose 0.13 as an example, something that isn't going to multiply into 1. So I'll take that, divide by 0.13, and pop that into the UV. And then to blend these two together, we have a couple of different options. I will add them and then multiply by 0.5 or divide by 2. And that is going to favor both noise maps equally. There are other things that you could do to favor the larger maps and then just apply the smaller maps on a smaller scale. For now, I will apply them both equally. Hit apply and then back in our material instance. Let's switch back to the UV to see what we have achieved. And I don't know why that isn't working super well. Perhaps this is too small. If we say something along the lines of 0.7, 0.3, 0.31. Alright, I know I wanted to avoid using a contrast node here, but it might be time to, instead of using this power, replace power with a cheap contrast. And replace the name distance noise power with distance noise contrast so that we can flatten out what this will do is it will allow us to use the contrast node to flatten out the gradients a little bit before we posterize them, which hopefully will give us bigger and more even sections. So if we set our contrast relatively low, we've managed to break up the smaller patterns as well as the bigger patterns. Okay. I think that should do it. It's worth experimenting with what works for you. I guess I usually use the contrast. I was trying to be fancy today and use power, but that didn't really work out as planned. But in general, the idea of what we're doing here is somehow mixing around the UV maps before we apply them as UV maps to the texture samplers. One thing to note about this is, let's go back to our map. I am going to quickly remove this depth fade by just changing the length to 1 and the offset to 1. So the fade is happening super close to the camera, which means that everything that I see right now is the distant noise. And turn this back to the mud texture. If you look carefully, you might notice some seams. For example, here is a rock that has been cut off halfway through. And those seams will correspond to, in our UV example, breaks in where the noise map has transitioned from one rotation to another. You might be tempted to say, oh, this works well to break up noise close by, so let's use that close up. But it is dangerous, because if you have both your noise maps and your normals, you might start seeing some artifacts where specific sections of your material have cut off, or where there are seams between one rotation and the next. In this case, it doesn't actually seem to be too bad, but depending on your configuration, you might have those seams, which is why I generally stick to using the fade, because our near noise doesn't change the UVs, it just fades between two different textures, or rather, it doesn't change the UVs on the fly, it just fades between two textures, so you can get that more gradual fade between the two different textures. The last thing that I'm going to do is adjust the fade length, because it's a little noticeable for me that there is a fading, that I'm fading between one mapping and another. So I'm going to increase this to about 7 meters of fade, starting 8 meters away from the camera, and then the fade is a little bit further in the distance, which makes the fade a little less noticeable. Alright, that's it from me. To briefly review what we did, we covered 3 different techniques for detiling your scene. The first was a simple macro variation, where we vary the brightness of the original texture based upon some scaled up noise map. The second was to take that color and sample it in 2 different ways. So the original coordinates and then rotate the coordinates. Just to be clear, you don't necessarily have to use the rotator. You could also offset by a certain amount, or flip the coordinates. Anything that gives you a little bit of variation between the 2 different textures. And then we used a noise map with a high contrast, so that there's a clear difference between bright patches and dark patches to blend between the 2 different textures. Lastly, we looked at adjusting the UV map itself, using noise maps to break apart the incoming texture coordinates before sampling them as UVs, in which case you only have to sample a single texture per texture, unlike the near fields. Each of them has advantages and disadvantages. The macro color variation is good for breaking apart vanishing lines far away, but you might not want that color difference close up. Blending between 2 differently sampled textures is good for things that are close up, because you won't have very clear seams in your material, but at a small scale, it's not great to avoid vanishing lines or grid patterns further away. And adjusting UVs before sampling the textures is great for really breaking apart your grid far away from the camera, but it does leave visible seams in your material, so you might not want to use it close up. We have done a lot, and there is already quite a big material node tree, and this is without any additional landscape layers, just a single layer, and any additional textures such as roughness or ambient occlusion or displacement. So if you are building your own landscape materials and you are applying these concepts, I would suggest wrapping a lot of the functionality of these nodes into material functions, so that then you can reuse the displacement or the rotation without actually having to copy and paste all of the different areas of that. The concepts should still apply regardless of how many extra textures you bring in or extra landscape layers you are using. Alright, that's it from me. I hope this has been useful. Good luck in your landscape projects and take care.